Let us now understand some other graphs. For example, we might also have an equation of the format x square plus y square is equal to r square. So this equation is called the equation of the circle. So if I just draw a circle here and mark these points, this is the coordinate axis. So this is the point 0 comma 0 and the radius of this circle is called r. Radius of the circle is r units. The center is 0 comma 0. So such an equation signifies a circle which is having the center at 0 comma 0 and radius is r units. So in this case it's small because I have taken small r. Now we might have an equation wherein we might also have not 0 comma 0 as a center but something else as the center. So in that case what we do is this center, let us say, is alpha comma beta. It might be any center, it might be 2 comma 3 minus 1 comma 2. It might be there in any random x and y in the xy plane. What I mean is, suppose this is xy plane, our circle could be here. So in this case, this is some other point. So in that case, suppose we are having a similar equation and the radius over here is also r. I'm going to write the equation as x minus alpha the whole square plus y minus beta the whole square is equal to r square. Example, let's take an example. Let us say we are having the equation in this format. What this means is we are having a circle. This is a coordinate plane. This is a coordinate axis. And this point is going to be 0 comma 0. The radius of the circle is going to be 3 units because r square is 9. So r is 3. Some other example maybe. Let us say this time we are having a circle here, and in that case let us write this point as 3 comma 4. The radius of this is 1 unit. Now we have to write the equation of this circle. How do you write that? X minus 3 the whole square plus y minus 4 the whole square is equal to 1. That's the equation of this particular circle. Likewise, you can take some examples by yourself and even you can generate the equation. In general, summary of the discussion till now, what I've told you is any format of this type means it's a circle. Any format of this type means it's a shifted circle and not at the origin. Let us take another curve. This time, it's something like circle but not circle. We call it ellipse. So, an ellipse looks something like this. And this time, these are the coordinate axes. So we say that this is the major axis and this is the minor axis. So this we would call as the major axis and this is the minor axis. So the length of this is 2a. We name this point as a comma 0. We name this point as minus a comma 0. You can see that this is a units, this is a units. Together the length is 2a units of the semi-major major axis. If this is the minor axis, the length of it is, this is 0 comma b, 0 comma minus b. The length of it is 2b. In general, we write the equation of this as x square by a square plus y square by b square is equal to 1. We could also have, just like a shifted circle, we could also have a shifted ellipse. In that case, we are going to be experiencing something similar. However, this time the center is something else. Let us take the center as maybe alpha comma beta. That means the ellipse is something like this. The ellipse is located here in the xy plane. And this point, precisely the center of the ellipse, is alpha comma beta. In this case, the center of the ellipse is 0 comma 0. So this equation is going to be x minus alpha the whole square by a square plus y minus beta the whole square by b square is equal to 1. The next curve in line is called rectangular hyperbola. So any equation of the format xy is equal to c is going to be written as rectangular hyperbola. And what we understand from here is that suppose I take the equation xy equals to 1. Just consider this. So what I've done is I've taken c greater than 0, c is positive. C is positive, then how the curve looks like, that we're going to see. So you can observe from here the nature of the curve. As x value is going to increase, we are going to first talking about positive x values. That means to the right of 0, all these values. So if x value increases, first you put 10, then you put 100, then you put 1000, then you put 10,000, keep increasing the values, you realize that the value of y is decreasing, which means that just near to 0, very close to 0. Of course, we can't put 0 directly over here because the equation will become not defined. So it's almost touching infinity, then it decreases, and finally it goes to 0. So at what point it will go to hit 0? It's going to be hitting 0 at infinity. So we say that the style of saying is as x tends to infinity, y tends to 0. As x tends to 0, as x tends to 0, y is tending to infinity. So this is the story on the positive side of x. What do you think will happen on the negative side of x? Stop the video and try it by yourself. Yes, so let me tell you what will happen. Exactly similar thing is going to happen over here. That is for all the negative values of x that you're going to put over here. Minus 10, minus 100, minus 1000 and so on. You're going to get negative y values, which is going to be this way. So we will say that as x tends to minus infinity, this is of course the negative end, so minus infinity, as x tends to minus infinity, y is tending to 0. And as x tends to 0 from the left hand side over here, y is tending to minus infinity. So this is the curve when this quantity c is positive. Now if I take a very specific case over here, you can imagine what I'm talking about. There will be a one specific point here. That means that 1, what will happen is, we'll get y also equal to 1. So this is that point 1 comma 1. Exactly over here, minus 1 is going to give us minus 1. So specifically I'm talking about this equation now. You can think for yourself what this point is going to be over here when it comes to this curve. Let us take another example this time. But this time we will take xy is equal to minus 2. So this time I have taken c less than 0. What is going to happen? Let us check. Obviously, if I put x as positive, imagine if I put x as all positive values, the final value of y is going to be negative. So if I put x equals to 2, I'll get y as minus 1. If I put x equals to 20, I'll get a negative value. So for all the positive values of x, what I'm going to get is negative value of y, which means that the nature of the curve in this case is going to be something like this. And if I put negative x, of course I'm going to get positive y. This is the nature of the curve. So Many a times in physics, we realize that as x increases, y is going to be decreasing, and vice versa. That means when one quantity increases, the other decreases. And in that case, we say that y is inversely proportional to x. Let's take one more example. This time, the function that we are studying is called an exponential function. The function that we are going to talk about is exponential function. So exponential function is always of the type y is equal to a raised to x. Now what is a? A is a number which is greater than 0, sorry, which is greater than 1 in this case. So maybe it could be 2, it could be 3, it could be 2.5, it could be 3.75, it could be any number which is greater than 1. If you are talking about the cases wherein a is greater than 1, then the curve is going to be looking like this. So what this means is that, suppose, let us say we consider the curve 2 raised to x. Now, as you keep putting the values of x on the positive side, they start from 0. If you put x as 0, what are we going to get? 2 raised to 0 is 1. Anything raised to 0 is 1. So over here, this quantity is going to be 1, 0, comma 1. Now, as you go ahead, as you keep increasing the values, let's say we start from 1. If you put x equals to 1, the value that we're going to get is 0, comma 2. Sorry. This point, of course, is 0, comma 2. But then the corresponding point over here is what I was talking about, which is 1, comma 2. If you similarly keep putting the values of x, that is 2, 3, 4, and so on, you will see it's a powers of 2. And naturally, it's going to be increasing very, very fast. That if this is 2, this is going to be 4. If this is 3, it is going to be 9, and so on. Let's come on the negative side and see what is going to happen. If you put minus 1, 2 raised to minus 1, 2 raised to minus 1 is nothing but half. So this value, this point over here is minus 1 comma half. If I put minus 2 over here, I'm going to get minus 2 comma 1 by 4. So as you keep increasing the powers to the negative side of x, this quantity is going to decrease. And we can say that as it goes towards minus infinity, it will gradually touch 0. Likewise, similarly, what we can say is, if as the values of x increases and it touches infinity, what will happen to the value of y? It will go to infinity. So this is the nature of the curve, a raised to x. So in general, many a times you will experience that you are being asked about e raised to x. Now e is an irrational number like pi, and we say that approximate value of e is 2.71. So it is like saying 2.71 the whole raised to x. So the curve that you must know is this. Let us say now a is less than 1. Can you imagine if a is less than 1, what is going to happen? Let us draw the curve. So this time we have, again the curve is a raised to x, but a is less than 1. Maybe as a specific example we could take up 0.5 the whole raised to x. In that case, you can imagine 0.5 the whole raised to 0 is 1 again. So this point is satisfied, that is 0, 1. If I keep increasing the powers of x, that is 0.5, the whole raised to 1 is going to be 0.5, which is over here, this point. 0.5 the whole raised to 2 is going to be 0.25, which is still smaller than this particular curve. It's going to be coming here. And looking at the trend, it is quite obvious now that as it takes higher and higher values of x, it's going to be decreasing in the values. And let's take on the negative side. If I take 0.5, the whole raised to minus 1, what is this? 1 by 0.5, which is nothing but 2. In that case, it's increasing. So as you come on the negative side, it's increasing. So as x tends to minus infinity, y will tend to infinity. So this was just so that you get some feel. The nature of the curve when a is less than 1 is going to be this way. Now let us say that we have something like y is equal to e raised to minus x this time. How to interpret this curve? Let us say that this was our mainstream curve, e raised to x. Now, whatever is going to happen to the part of e raised to x, I'm just writing it this way. Now, this was for e raised to x. Now, you are saying that all these values that are taking up, that means e raised to 1 was giving you the value of e. However, to generate that value over here, you will have to put x equals to minus 1. That means the value of y that was coming at x equals to 1 over here, you're going to get that at x equals to minus 1. The value of y that you were generating at x equals to 2 in this curve, that you're going to be getting at x equals to minus 2 over here, which means that e raised to minus x is a curve which is exactly the mirror image of this, and the curve is going to be like this. Let us still create another transformation exactly in the same graph. This time, I'm going to take the curve as y is equal to 1 minus e raised to minus x. How is this graph going to be? So as far as the transformation is concerned, now this is a equation. This is a equation and a graph that is very frequent in physics. So it's a good idea to have some understanding about this. So e raised to minus x. Just consider e raised to minus x. The graph was something like this. Now suppose we have the minus sign attached to this, then all the values that you were getting are going to become negative. And the graph is going to now look something like this way. So this is the graph of y is equal to e raised to minus x. But if I add a negative sign to it, this is what is going to be looking like. Now I have added 1 unit to it. So you can see that I've added 1 unit to this particular part. Naturally, it's going to be shifting overall on top. This part is going to be shifting on top now by 1 unit. So the graph actually is going to be looking this way. So let us show this graph. And this point naturally is 0 comma minus 1. This time we are still going to be getting a negative part, but this time it's going to go from here this way. So that is the curve of y is equal to 1 minus e raised to minus x. If I'm just interested in positive values of x and I tell you that it's not going to take up negative values of x, the curve that we're going to be seeing is somewhat like this. That means I'm just interested in the positive values of x, and this is the curve that we're talking. So this is what we are interested in. The curve is going to be looking like this.